I just wanted to echo Meredith's welcome to everyone. We're really glad to see all this interest in the talks that we have today. I'm Zoe Corville. I work for the U.S. Army Corps of Engineers at the Cold Regions Research and Engineering Lab in Hanover, New Hampshire. I'm one of the co-leagues for the Glaciers and Sea Level Community of Practice, along with Caitlin Harbeck from NASA, who's also here. I'm going to put in a quick plug for ARPIC. It's the Interagency Arctic Research Policy Committee, and it's really aimed at coordinating Arctic research activities and objectives amongst the different federal partners. And we were just discussing this before getting started. There's a lot available on the website about different activities and the different communities of practice, of which this is just one. And different communities of practice hold different meetings and have different schedules. So there is a lot going on. The communities of practice are really meant to help facilitate collaborations between federal partners, academic institutions that are non-federal, and Arctic communities. And so there's a rich wealth of information that's available amongst all these different groups that are working together. Today's meeting, we're going to be focused on NASA's SnowEx campaign, which is a very extensive and has been a many years long, both airborne and field-based campaign that many in the snow community are a part of, both nationally and internationally. Pretty much anyone that's studies snow in some form has been a part of it in some way or another. And it's really done a lot, I feel like, to bring our community together and to also forward a lot of education and mentorship opportunities as well. And so we're really lucky to hear from 4 of the SnowEx team members, HP Marshall from Boise State, Carrie Vuyovich from NASA, Goddard Svetlana Stuefer from University of Alaska Fairbanks, and Megan Mason, also from NASA Goddard. I will also put a plug in for the SnowEx group, because this will really just be the tip of the iceberg for SnowEx activities. And there will be a lot of SnowEx-based AGU presentations next week. So if you're going to AGU and you're interested, you should check out more of what this group has been working on for sure. And with that, I'm going to turn it over to HP, I think, is our first speaker, who's going to go over the overview of SnowEx.
Great. Well, thank you, Zoe, and to the rest of the IARPIC group for this opportunity. Thanks for the intro. We're going to be chatting about the SnowEx mission. There's a lot to cover here. This is going to be a bit of a fire hose, but check out snow.nasa.gov, and there's a lot of information, including recordings from a lot of our meetings and a lot of presentations that have happened that have gone over a lot of this material in more detail. So we're going to just go through a quick 10 minutes on goals and community building and open science. Carrie's going to talk about airborne and field campaigns. Then Sveta will talk about the most recent SnowEx campaign in Alaska. And then Megan will wrap it up talking about how we're dealing with QA/QC and data publications and availability of these data sets to the community. So just first, I'm sure everybody kind of knows this, but for those that aren't as engaged in seasonal snow in particular, over 1/6 of our population, the global population, depends on seasonal snow for water supply, and 70% of our water resources here in the Western US come from seasonal snowpack. It also has a really big impact on albedo and the global energy balance. It's an input for glaciers and ice sheets, but it's pretty challenging to measure and model, especially in the complex mountain terrain that a lot of the water resources exist. In terms of snow, we've got really short length scales of variability that require very high resolution observations, dynamic changes on scales of hours to days. And currently there's not a satellite remote sensing product for SWE that works well in mountainous regions operationally. And the models also show a pretty wide spread, both in space and time, largely due to the uncertainties in the forcing data. And with climate change, these patterns are changing. We're getting earlier melt, more frequent rain on snow, changing snow lines. And so we really do need a global solution for snow monitoring, especially in remote regions. And the seasonal snow community that's involved in this has really settled on the fact that it's going to require a fusion of remote sensing models and field observations, and not really just one type of remote sensing. So what is SnowEx? It's a multi-year coordinated airborne and ground experiment that we've been doing to evaluate different types of technologies in lots of different snow environments. And the goal of this is really to help inform an eventual satellite mission. And so we've got a bunch of gaps listed there that are largely different snow climates, but then also the transition to wet snow, vegetation impacts, and snow surface energetics. There's a SnowEx science plan that's listed on the URL, and I know these slides will be made available, so don't worry about writing that down at the moment. Just to put this in context, sort of the timeline of major community-wide airborne seasonal snow remote sensing efforts. The first really big one was in 2002, 2003, the NASA Cold Land Processes Experiment, or CLPX or CLIPX, as people have called it. This is kind of the first big coordinated remote sensing effort with lots of different instruments and an army of field observers. We didn't make it very far in the decadal survey in 2007, so then effort shifted a lot in terms of these kind of campaigns to Europe and the European Space Agency's Core H2O program in Finland, Austria, and the Canadian Arctic. And then after the last decadal survey, a lot more momentum, and kind of kicked off these series of SnowEx campaigns that we'll be talking to you today about. And that started in 2017 in both Grand Mesa and Senator Beck Basin. And then in 2019 and 2020, some more extensive observations at Grand Mesa. We then followed that with a time series of L-band INSAR over a wide swath of the Western US, a whole bunch of different sites in different snow climates. And then in the last couple of years, we've been up in Alaska, specifically testing LiDAR structure for motion and X and KU band SAR in the boreal and tundra snow climates. And you'll hear more about these different efforts. This is just a real broad overview. The goals of the Grand Mesa efforts were to collect the data needed to test and validate SWE retrievals from both active and passive sensors, look at what happens to these retrievals in forested environments, and also look at snow surface temperatures with thermal IR. And this was done, we started in a pretty flat place in Grand Mesa. It's the largest mesa in the world at 11,000 feet with very little large-scale topography. And we had a paired site at Senator Beck Basin that's in really steep terrain. The time series was really getting us prepared for NISAR and trying to leverage the US Indian satellite mission that's going to be launching sometime in 2024. And so that approach is using L-band INSAR and using those phase changes to map changes in snow depth and SWE. We flew 14 total sites across 6 states. We had over 100 people involved, including all the efforts on Grand Mesa. And we were able to do this during a global pandemic because we had a lot of local field observers that went out on the day of each of these overflights. Kind of the brief summary right now, papers are starting to come out on this. Good agreement with LiDAR and flat terrain, still working in steeper terrain, although with larger uncertainties. We've been measuring SWE loss even, which we didn't think we could do with early enough morning acquisitions. And even some signals in prairie snow where it's really, really shallow that are kind of on par with LiDAR. And some newer work seeing promise with this technique with the Sentinel C-band satellite, which is not as ideal. NISAR will be much better. So then in Alaska, we moved up there to cover that tundra and boreal snow environment and to test both radar and LiDAR and structure for motion, and specifically how the sort of freeze thaw permafrost is influencing those retrievals, how snow and vegetation impact that permafrost, and what kind of factors control the variability of accumulation and ablation in the Arctic. And data assimilation is always a pretty big piece of what we're trying to do to integrate models and remote sensing. Just a couple more slides for my part. The Snow School programs, we've got a couple different areas of that. One that's a collaboration with Kawasi. And these are 3-day hands-on field schools that have been taking place since 2013. They usually involve about 30 participants, and they get a lot of experience with standard measurements and exposure to new technology, and it helps prepare them for future SnowEx campaigns as well as other activities. And then for the younger generation, we've got the Winter Wildland Alliance Snow School. This is a K through 12 program that involves over 35,000 students across the US. And there's 80 local programs. So if you're interested in getting involved, they're always looking for scientists that can engage with these grassroots organizations that bring kids out into the snow and do snow science with them. Then the last community outreach I wanted to point to is the SnowEx Hack Week. We did this in person in 21 and 22, and then a virtual version, or sorry, virtual in 21, in person in 22, and then a semester-long virtual one as well in the fall of 22. It involves a bunch of programming, instruction leading up to the week-long event. We have a team of 25 tutorial developers and organizers that spend about 6 months planning the event. It's a week-long in-person. The in-person one was a week-long with half-day tutorials in the mornings and then half-day group projects in the afternoons. And it was really amazing to see the kind of progress that these folks were making in just 1 week. It created a lot of long-term collaborations and really strong connections, in particular between master's and PhD students across universities that have continued to work together. It also produced a lot of tutorials and database access, sort of helping with database access by generating this new database that includes all the observations and making that available to the community. And it's really helped students kind of ramp up quickly. They have this place they can go through a Jupyter notebook and get up to speed with any of the SnowEx data sets. We're always recognizing that diversity and equity in the geosciences is super important, and that there's been almost no progress in terms of racial diversity over the last 40 years. So we really try to encourage people from all backgrounds, races, religions, and gender. And we do feel like the open science approach that we're taking creates this environment of equity in access to data and software and promotes inclusion. And the snow schools help people get over that barrier of getting out into the field, but we're always looking for suggestions on how to improve. And so with that, just a list of some of the collaborators and coordination that's not funded by SnowEx that we've lined up in the past. This is an example from 2020, 21, where there's a lot of other government organizations that are doing snow observations, and we kind of help to line all of those things up so that everybody can take advantage of the validation and the sensor fusion opportunities there. And just snow science is a team sport. There's one of our core or really critical team members, Zoe, doing some microstructure in one of the pits that's critical for the retrieval algorithms. There's a link if you want to look at these slides later to the science plan and one of the experimental plans. And with that, I'll turn it over to Carrie to go into more detail on airborne and field-based aspects.
Great. Will you keep advancing the slides? Okay, great. Yeah, so I'm going to just go into more detail, like specific sensors that we use and specific measurements that were collected during each of these different campaigns. So next slide. I guess, HP already gave a really good overview of why we're doing this. This slide is really meant to speak to why do we need a satellite? Why does NASA care about all this stuff, measuring snow? And I think really, it's just the vastness of the global snow cover that lends itself to a satellite observation. It's really well suited to provide the spatially distributed, the temporal frequency that we need. So snow covers about over a third of the Earth's land surface each year, and a lot of that is up north in the Arctic areas and in places where we don't have any observations. So satellite is really the right approach. We have a number of different seasonal snow observations that are really critical. Albedo, snow extent or snow covered area, the surface temperature, and SWE or snow depth. The first three of those, we have satellites already providing some of that data, and there's been a lot of advances over the last decade or two in developing algorithms and retrieval approaches so that we have that data. There's still some open questions and uncertainty in certain areas, how well we're retrieving albedo and snow-covered area that were part of SnowEx. But we are further along there than we are with SWE or snow depth, where we've never had a mission that provides global SWE or snow depth information that we really need to answer some of the science questions and also to support a lot of the operational or application areas. But as HP mentioned, a lot of the approaches we have, there are a lot of challenges. They're all kind of impacted by different challenges. And so I think the community has pretty much recognized that it's probably going to be some combination of multiple different sensing techniques and models to give us kind of a consistent, accurate SWE information that we're looking for. So next slide. But one of the big objectives of the whole SnowEx effort has been to prepare the community for upcoming mission opportunities. So help us understand how well these different approaches work in different conditions, as HP mentioned, and then advance them so that we're in a place where we can leverage some of the data coming available for upcoming or existing missions, or be prepared to propose to opportunities that come up. So some of the upcoming opportunities that we've been looking at are one NISAR that's expected to launch this year in March. And so that was a big one. There have been, some promising results with the L-band INSAR technique. TSMM is the terrestrial snow mass mission. This is a Canadian-led mission concept using dual KU band SAR. They've been working on for a number of years, and I think it's in pre-phase A at this point. SPG is a decadal designated observable that is planned. It will measure hyperspectral and thermal IR observations, and the albedo folks are really interested in that, for helping with the, getting those albedo observations. So a lot of the SnowEx effort has been making sure our algorithms for snow albedo are working and in place in preparation for SPG. And then the Earth System Explorer solicitation, this came out in the spring, and that has been a big focus of SnowEx, making sure that the snow community is prepared, has a technique that's viable to propose, understands how well it'll work in different places, and gearing up for that solicitation. So proposals were due in August, and there were 2 snow mission concepts proposed that I'm aware of, one using X and KU band SAR and one using P band signal of opportunity. In addition, there are some existing satellites that have just recently shown promise or have been developed into better snow information. One is using C-band data from Sentinel-1. There's also a lot of stereo photogrammetry data available from, especially from a lot of commercial platforms, Worldview, Planet, Pleiades, Black Sky, that have shown that you can get fairly accurate snow depth information from stereo pairs, and then spaceborne LiDAR, especially from ISAT-2. It really wasn't designed for seasonal snow, but we use airborne LiDAR a lot, and so there's been a lot of work looking at how well we get snow depth from ISAT-2. Okay, next slide. So this was kind of an exercise that the SnowEx community planning group went through early on. This is in the science plan if you want to take a look at it. This is specifically for snow depth and SWE. Here are all the snow sensing technologies that people are using, that we're aware of, and the point of this exercise was to identify where we are in terms of maturity and potential, and are these viable mission concepts for the future. And so we had kind of ranked these. There's question marks next to the TRL levels because everybody has a little bit of a different opinion, and I'd say this is probably out of date at this point. This was done several years ago, and I think we've advanced different techniques, but it was a really useful exercise going through all of these, and it helped us kind of prioritize what was flown during the SnowEx campaigns. And I would say we've flown almost all of these instruments during various snow campaigns, some on the more experimental side to support kind of a small study, and some were prioritized a little bit higher as they were more geared towards upcoming missions and the Explorer call. Okay, next slide. So one of the first part, like when we're developing these campaigns, one of the first pieces, once we've identified the science questions and kind of prioritized which instruments we want to look at, is putting together the airborne piece of this. Once we've selected the sensing technologies we want to use, then we got to figure out which instruments are out there, what aircraft they fly on, what funding mechanism to get them in place, the timing, the availability. I would say this was a significant portion of the whole SnowEx effort, was getting the airborne piece together. And it kind of had to happen early on because there's quite a long lead time for this. Next slide. So this is a table of all the SWE or snow depth sensors that were used during the campaign. And I'm not going to go into too much detail on this table, but there were a few things I just wanted to point out. One is that LiDAR very early on was determined to be kind of essential to any SnowEx campaign. Airborne LiDAR has been used successfully to get very accurate snow depth information over a large area. And so it was one used to test that approach in different locations, but then as validation for all of our other measurements, a lot of these other sensing techniques. And it kind of, you know, when we first started, ASO was being flown at JPL and was just being demonstrated as, you know, a really an excellent way to get good observations over a watershed scale area, to the point now where ASO is a, you know, a commercial company and they're flying over on a regular basis over watersheds in California. So that it was, you know, it's been interesting to see that development, and it was definitely a critical component of our campaigns. UAV SAR was also, I think, so that's the L-band INSAR instrument that it's flown on the NASA G3, and is also a good example of a technique that's matured over the lifetime of SnowEx, where in the beginning it was kind of experimental. We'll fly in 2017. The results were really promising and really exciting, and it turned into this whole time series campaign in 2020 and 2021. And then similarly, just point out the SARS, so an XKU band radar has been flown in 3 of the different campaigns as well, 2017, 2020, and this most recent, 2023. And so that was another kind of high priority. And then the 2 at the bottom are not techniques that have path to space, but provided good information. And those were 2 partners that were flown. And the one I forgot to put on here was the Corral helipod, which was also flown over some locations in Idaho as well, which was great. Next slide. This is a list of the sensors that were flown to collect surface property information. So albedo, surface temperature, and optical sensors. In 2017, the CAR instrument was flown to get VRDF and albedo. In 2017 and 2020, there was a hyperspectral instrument flown with ASO and quantum spatial. But then really thinking towards SPG, AVRS-NG was used in 2021 and 2023 because of the wider frequency range, and to test how well our albedo snow retrieval snow albedo retrievals work in mountainous basins as well as boreal forest. Next slide. So once we have the airborne instruments determined and all of that's in place, then we can start planning the ground campaigns. And every campaign, we took a lot of measurements, and the combination of both manual measurements and a lot of ground-based remote sensing measurements that were kind of determined how best to validate the sensing techniques were used and how best to answer the science questions that were posed. Next slide. So this is just a list of kind of all the data that has been collected, and there's probably stuff missing on here, but just kind of high level list of the data that we've collected during each of the campaigns. I'll say snow pits are typically our gold standard. You know, that's kind kind of the core measurement that we're collecting within the pit, a lot of snow information. The protocol changes a little bit with each campaign, but in general, that's been kind of our gold standard measurements, as well as snow depths, trying to get as kind of a broad snow depth coverage as we can. And then the ground-based remote sensing microstructure has been really critical for a lot of the radar sensing techniques to understand how the snow grain size is affecting our measurements. And so there's been always some microstructure measurements as well as different radars and radiometers out in the field as well. Next slide. I think this is my last slide. So then it's all kind of put together. We have our airborne instruments, we have our ground-based measurements, and then kind of designing the measurement strategy comes down to a lot of other considerations, like where we have access, where the airplane flies out of, what different terrain characteristics we're trying to cover, how many people we have, and so this is kind of like the different campaigns, how we've put that together. So in 2017, as HP mentioned, we were in Grand Mesa and Senator Beck Basin. 2020, we had this time series that covered all the Western US, plus this intense campaign over Grand Mesa. And then in 2021, just the time series part. And in 2023, we're up in Alaska, which Sveta will talk about.
Thanks, Carrie. And thanks to Zoe and IARPA Group for organizing this community meeting. My name is Svetlana Stuefer. I am Associate Professor of Civil and Environmental Engineering at the University of Alaska Fairbanks. And I'm physically here in Fairbanks. It's 10:30 in the morning and sun is about to rise over the Alaska range. It's been a great experience to live and work here on the ancestral lands of the Dana people from the lower Tanana River. And most of my work during last 20 years took place here in Arctic and interior Alaska. And in 2021, I joined SnowEx team to help and work on the Alaska effort. So next slide, please. Yeah, very nice. SnowEx is truly a community effort. In Alaska, we had more than 100 participants from at least 20 institutions in the United States, Canada, and European countries that came here to work on 4 campaigns that we had during last year. The core organizing team listed here has 12 members and is led by Carrie Vuyovich. Next slide, please. SnowEx, why Alaska? SnowEx science plan, and the link is listed on the slide, identified gaps in modeling and measurement techniques specific to boreal forest and tundra snow cover. And I would like to take a moment and talk about this type of snow covers in Alaska. And next slide, please. Carl Benson, Professor Emeritus here at UIF, called Alaska back in 1970s, and I'm gonna cite his words, made to order snow laboratory, because it has Arctic continental and maritime climate zones in proximity. The Arctic coastal ranges, they separate North Pacific maritime climate from severe continental climate kind of within the interior Alaska. And the Brooks Range up north separates interior continental climate from Arctic polar climate. So the differences in snow cover characteristics from one climate zone to another, they are striking. On the right side of this slide, you can see a recently updated global snow cover classification by Matthew Sturm and Glenn Liston. And so they show that over the 50% of global snow is within tundra and boreal forest snow classes. And Alaska is especially well suited to study this type of snow classes. Okay, next slide, please. However, permanently frozen ground, permafrost, active layer, the seasonally thawing ground, and the land cover, they represent unique challenges for remote sensing of snow in tundra and the boreal forest snow covers. Work by Chris Heimstra here shows a conceptual diagram that emphasizes the effect of the forest cover, organic layer, shrubs, and air voids on our ability to measure snow and snow water equivalent in these environments. And next slide, please. Thanks. And to address these challenges, SnowEx has identified 8 objectives specific for boreal and forest snow. HP and Carrie, HP mentioned earlier on some of them, but here they organized in 3 classes: measurement science, snow science, and information science. So to next slide, please. The planning phase for SnowEx Alaska campaign to address the science questions started in 2021, and the first field campaign, it was low snow campaign, took place in October 2022. Then snow on field campaign was held earlier this year in March 2023. It was followed by albedo campaign, and just within last month and a half, we completed the last SnowEx Alaska campaign in October 2023. Okay, next slide, please. And I'm just gonna take 5 minutes and show the study areas, give a general overview of measurements taken, and show a few pictures for airborne and ground-based measurements. So the snow study sites, were selected based on science objectives, and they span diverse boreal forest on the left side of the graph and the Arctic condition, that central North Slope map. 2 study sites represent tundra snow cover. They're located on the Arctic coastal plain and in the foothills of the Brooks Range. This is the area of continuous permafrost and low-growing vegetation. And the 3 sites that you can see on the left map are selected in the boreal forest near Fairbanks. Okay, next slide, please. Next 2 slides have the same layout, and they show the overall summary of this one for the October 22 campaign, and the next one for the perfect March 2023 campaign. I'm just going to spend a moment on this slide and point out that we have set of ground measurements, ground-based measurements, airborne measurements, and the satellite data tasked during the same time period. So, for example, in March 2023, we had more than 50 people collecting ground measurements on on the ground, and the measurement protocol included snow density, snow temperature, stratigraphy, permittivity, and detailed measurements of vegetation and substrate characteristics. Snow depth measurements were collected at each plot perimeter and around the plot. We also had microstructure measurements, in this case at 80 plots, terrestrial laser scanner, GPR measurements, C-band, at all 5 study areas from Arctic coastal plain to boreal forest. On the airborne side, we had a LiDAR and stereo data collection operated by Chris Larson here at UIF. And these measurements were taken concurrently with ground observations and were following shortly after the SWISAR radiometer and radar instrument, airborne instrument. And that effort was coordinated by Batu Osmanoglu from NASA Goddard. Again, and on the right side, there is a set of satellite data. Next slide, please. And I'll just take a few more minutes and go from the most northern side, Arctic coastal plain, to the Kuparik and then to the Fairbanks area to show a few pictures and extent of the data set. Okay, next slide, please. Here we are on the Arctic coastal plain. You can see the shallow tundra snow, and there are also present, snow drifts are present. On the left side of the slide, you can see green and red lines, which represent LiDAR and SWISAR data collection. Next slide, please. Moving further south to the northern foothills of the Brooks Range, this particular site has 3 LiDAR swaths shown in red outline, and also 3 SWISAR swaths shown in this turquoise color. And within each of the airborne swaths includes the ground-based measurements shown kind of in red colors. Also, this particular site had 9 corner reflectors near Galbraith Lake used to calibrate airborne SWISAR data acquisitions. Next slide, please. Now we move south of the Brooks Range in the subarctic, in the boreal forest area, and at this area, we spent quite some time measuring tussocks, forest, mosses, substrate layer, and sometimes mineral soil at each plot. Here we can see examples of the organic plaque, the material the snow covers sit on. Perfect. Farmer's Loop and Kramer's Field. Okay, or yeah, few more pictures and different vegetation around Farmer's Loop, Kramer's Field. Next slide, please. Another forested site, Bonanza Creek Experimental Forest. This particular study site also had a corner reflector experiment led by Mike Durant and extensive TLS scans. In the last slide, I'd like to acknowledge the terrestrial hydrology funding for Alaska effort, and do say that we had a lot of local support in Alaska. UFLTR, Tulik Field Station, Fairbanks, National Weather Service Fairbanks Station. So we had, and many different organizations involved really made it a successful campaign. Okay, thanks everyone, and I think Megan is next.
Good job, everyone. Thank you. Yes, hello. My name is Megan, and thank you to my collaborators and everyone who invited us today to speak. So you've heard a lot about the data collection methods, and then I think everyone here knows a lot about getting data available and like getting your papers published. So we need to kind of talk about what it looks like and what SnowEx has done to make a plan to post-process this data and get it available. So I'm just going to touch on that. I guess right here we have our snow measurements, and then we have the data being transcribed on site. And then the picture on the right is showing one of the Hack Week events where we're all using the data. Oh, yep, there we go. So I just wanted to give you a quick professional bio on, who is Megan and how did she get here? So, yeah, I spent a lot of years in national parks and national monuments, which are really special places to me. Most notably, I worked in Yosemite National Park as a hydrology technician. This is where I learned a lot about data collection and kind of data management practices there. So that was really inspiring to me and made me want to pursue a master's degree where I went to Boise State and worked with Dr. H.P. Marshall. So I had an incredibly valuable experience there where I learned a lot more about the full data analysis process, and that was really meaningful. And I worked still with data in the Sierra Nevada and snow patterns, but I also got to do as much in SnowEx as I could do. So that helped me transition in quite seamlessly into a data support scientist role, working for NASA Goddard and our logistics and safety coordinators, contractors, the SSAI group. I'll mention that I'm currently residing in Berkeley, California. So feel free if anyone visits or lives around the area. I would love to connect. I'm trying to grow a broader network here. My current role, to expand on that, basically for the data management piece is I'm either leading the post-processing and review efforts of some of these major data sets, that's the snow pits, or I serve in a support role for some of our other core data sets, be it the DEPS or the SWE. These are like very significant data sets that you heard mentioned, and those require a lot of sort of back and forth and guiding so that they are consistent. And then I also facilitate the other instrument leads that go through the data submission process and help field their questions as they go through that. Other areas of general support have been being on the campaigns, taking the measurements, overseeing the data workflows that we have in place while we're on site, so that we're not just collecting pit books and bringing them home. We kind of are transcribing them on the spot. I work with some of the open software development opportunities when we have things like Hack Weeks. That's been really great to be a part of. And then for the last 3 years, I have been mentoring students it's part of our SnowEx intern opportunity with minority serving higher education institutions. So the photo on the right is showing visiting the school in Fond du Lac, Minnesota, and being with those students. So yeah, the whole kind of process from fieldwork to being with the NASA Goddard scientists. And then I will just mention that this photo in the middle with the leadership team in the background, it's a little outside the scope of this, but I really want to say that I think we've been so successful in so many ways because this leadership group has taken so much time to not only consider the science and the science objectives, but to really cultivate sort of this whole mission and experience. And I think I've just witnessed and benefited from so much of their mentorship in watching them make big decisions and sort of guiding this along the different campaigns in the different years. So I'm really grateful. Next. Okay, so back to the real point, I have distilled down what it takes. You heard earlier that we want to measure snow globally, and SnowEx is playing a big part in that. And the big part is creating these legacy calibration validation products. So I think that comes down, if we can always meet these three objectives, we will be able to produce those products. We're not perfect at it, but this is like kind of what guides us. It starts with quality data collection. This isn't something that just magically happens. This really does require a lot of planning and training up front. It also requires getting on the ground, assessing conditions for that campaign and the location, and then before the measurements start, really honing in on the consistent protocol that will be used in the measurements for that campaign. And we've learned doing that near real-time sort of data review so that we don't get stuck with something that was being done incorrect that we can't really go back and redo. And I think it's important to note that if you feel like the data quality is being compromised, to decide to like kind of have the plan in place to stop that. You know, it could be the instrument breaking, it could be the health of the participants, it could be the logistics, any of that, just knowing that you need to stop. So then we get to the point where we, you know, in any campaign, you can have all the field work, but to really dedicate a person or a group to be responsible and accountable to get these data from the raw format into a post-process user-friendly version is really critical. And in this case, it requires a little bit longer time because there is such like a manual component. We are asking people for a lot of qualitative comments and notes about it, and we're kind of using that to help create those data sets. And I think another thing that's really key is having that continued network and communication with people that took the measurements. That's really helped us go back and learn a lot. And it's always informative to recall how much they can remember about that day. And anyways, so then having, I think, the diverse community of users is the last critical piece, because you can put a bunch of stuff out there, but until it's really being used and the different ways it's being used, and until you get that feedback or until you announce and kind of show off these data sets, you want to make sure that you can get that feedback and apply it as you iterate back and through number 2 and number 3. So great. So the next 4 slides are just sort of like a little bit of a peek into what it's like to QA, QC a data set that is like one of our biggest, as Carrie said, like our gold standard is the snow pits. So I've used the example from the 2020 time series. The points that I want to highlight on this slide are it has worked best for me to basically conduct like a round 1 review. You are just doing a full-on handling a lot of easy typos, transcription errors, etc., making sure that everything on the paper was indeed transcribed, looking for erroneous stuff. But the most critical step in that is to record like the common themes of things that are relevant to either say a sampling group or a location, you know, something we didn't expect, or a way that things were getting measured that we need to either adjust or correct for, or write more detailed documentation for later on. So then bringing that information to the review group so that you can then create a criteria or maybe a threshold or like a flag of some sort to handle those issues that we found. It's one of those things where we think we've planned for everything, and then, you know, the snow had an interesting ice layer that we didn't really expect, and like, is that being properly described and consistent throughout the data set? So then you go back and you do the second round of revisions, and after that things become much more automated, and you're, you know, producing files that will then get published. So that's sort of a quick little insight there. to highlight the SnowEx 2020 time series snow pit measurements. These are the parameters that are coming from it. And this is like what the snow pit looks like with the grain card, where we're looking at the crystals and digging these snow pits in varied environments. And so it goes from that piece of field work into these parameter files where we split everything up into the different components of the snow pit. There's a series of photos that get published along with it. And then the raw snow pit book images are published along with that. We also produce these summary files that kind of summarize the pit environment and then the bulk properties of the snow pit, such as SWE and density, and those are all then made available. And so last, we try to highlight the things in the data set that users might want to know about. For example, I mean, this is, like I said, a really large data set. It happened over 12 different major areas in the Western United States and happened over a time series. So the data set is very rich with things like melt freeze crusts and horizontal ice layers and vertical flow finger, like frozen ice columns during the melting periods, surface hoar, the presence or the absence of it, dust layers, all things that different projects may want to incorporate. Lastly, we're always try to be as open and honest as we can about our sources of error. And most of that comes from, we just have so many folks taking these measurements, and we work really hard to standardize them and take them. But as you know, a lot of people, we all have our biases. So yeah. The last two slides here are just kind of showing how we get it. We go from the SnowEx side, and because of our assigned missions contract that we have with the National Snow and Ice Data Center, which is in Boulder, Colorado, how we get our data published. And so if you're on the NSIDC page and you're looking around for SnowEx and you look under the data tab, you can see what's in the first box. There is a really large table, and you can see all the products we have, and you can look at them by year. If you look at the middle panel, all of those products are given a landing page with a toolbox. The tool that I use the most is the user guide, and the user guide is generated by NSIDC and the data submitter, and they work together to produce a really nice document that gives a lot more information and provides something like, for example, in panel 3, the map that sort of shows the experiment design and sampling plan. And the takeaway here is that with NSIDC, they just offer a lot of different download options. You need an Earth Data login account to access it. You can do a lot of different download options. Quick file grabs, you can filter by spatial extent or temporal extent. So yeah, that's detail. I will say number 5 on there is we have sort of a lightweight option that gets different periods of building and then and pausing on development, but we work to develop a SnowEx SQL database. It helps to be a little bit familiar with some of the more data sets and stuff, but know that is an option, and it's something that has been a community effort in growing. Obviously, one person really led the way, but that's been a community effort in getting that in a place that's usable. So yeah. In my last slide, I'll just kind of give you a publishing progress status based on the different campaigns that you saw listed. We are just sort of tracking what we have published and, generally speaking, what is still expected. Now, expected is a little bit of an estimate because it depends on how many level versions we publish or how we split or lump different expected data sets once they become further processed. We've worked hard to get a lot of the core data sets out there first, and then we have a lot of other ancillary data sets coming along. So that's kind of where we're at. We hope that now that we're not doing things on the ground, 2024 is a big year of publishing, and that will be present in our monthly SnowEx community calls, similar to a call like this. So thank you guys so much. I realize we're at the top of the hour.
Great. Yeah. Do we have time, Meredith, do we have time for a few quick questions?
Yep. Yeah, I don't have a meeting
Okay.
right after this, so I'm happy to leave this meeting open for questions, but also if people need to drop off, definitely respect your time, and the meeting recording will be posted either later today or next Thursday.
And feel free to reach out to any of us by email if you have questions too.
So, yep, and if you do have a question now, you can either raise your hand or unmute or type it in the chat. I do have a question from Hazel, who had to jump off. It's kind of a broad question, but she said that she's curious about the planning process for a campaign like this. For instance, who decides the focus of the campaign broadly? What kind of participants are involved in setting the key questions that the campaign targets? And that you all mentioned a number of science goals, but that you saw the applications to more operational and applied work. So do you set specific goals around that or involve anyone from outside the Western science community in the planning process? And I'll put that question in the chat because it was many questions.
Carrie, in terms of your role at Goddard, do you want to take that or do you want?
Yeah, maybe we can both kind of hit on it. I think it started with there was, it's this whole thing has been sponsored by the terrestrial hydrology program, so led by Jared Enton. But he really, I think, likes to hear from the science community, wants it to be driven by the science community, what we do and where we go and what the priorities are. So in 2016, there was a THP Rose's Call, and a number of researchers throughout the community were funded under that. And kind of as part of their projects, everybody had their own individual projects, questions that they were interested, but that group was really started the discussion on what would SnowEx do, what should the priorities be, and then writing that science plan. And then over the years, as other folks were funded under THP or just were interested in becoming involved, that group grew. And so it really was a community-led, community-driven kind of science questions and where we should go next and what instruments should be used. HP, do you want to add anything to that?
Yeah, I mean, I guess just, leading up to that 2016 call, there were a bunch of community-wide snow remote sensing meetings where a lot of the priorities were discussed. So I think that was a big part that was taken into account. And then there was an effort to create a SnowEx science plan after the first campaign. And that there wasn't a big overlap between the group that was producing the science plan and the folks that were planning the campaign. So the science plan kind of called out a lot of the priorities, and then that was further discussed in some of these community-wide meetings. And then as a planning team, we tried to, follow the science plan essentially in terms of setting priorities.
That's great. I don't see other questions. I anyone has them, feel free to pipe up. But I appreciate our speakers today and everyone for attending. It was great to see a lot of new people attending today. And as always, appreciate Meredith's help facilitating this and IARPIC. So yeah, if there are no other questions, I think we'll go ahead and log off until next time.
Great. Thank you so much.
Yeah, thanks everyone.
Thanks, everyone.
Yeah,
Bye.
thank you.
Thank you all very much.